am having flashbacks to my first public talk at Apache several years ago, which was in a very long room like this. So I apologize to the people on the ends to start with if I'm not looking directly at you all the time here. I'm probably trying to use this screen most of the time. So if you do have a question, please let me know, and I will try to take a break to answer them if something's not clear. I do hope to leave time for Q&A at the end. So my name is Todd. I am a staff site reliability engineer at LinkedIn. For those who don't know what SRE is, site reliability engineering, because not everyone's familiar with it, this is not that far from the truth. My team goes through a lot of fear. In fact, I was just at a brewery this morning working on a new recipe. But our job is to know what's going on with a specific application, keep it up and running all the time, and make plans for architecture, make plans for capacity. We write tools around it. So we're a combination of developers, we are architects, we are operations guys. I'm on call 12 by 7. Thankfully, I have a team in Bangalore to help me out so I can sleep at night. But that's in general what I do. So we're going to talk about Kafka today, and we're going to specifically talk about some of the interesting problems that we run into. So these are the things that I'm going to try to cover. I'm going to talk about multi-tenant pipelines, which is how we lay out Kafka at LinkedIn, and multi-tier architecture. Those go together. Then we're going to talk about the interesting problems that I've run into and some of the tools we've developed to fix those. And then going to wrap up with a couple of things that we're working on now and have some time to answer some of your questions as we go on. So to start with multi-tenant pipelines, what I mean by this is that we run Kafka as a service at LinkedIn for everyone. So I don't know much about what's happening as far as the data that's going through Kafka. I run the Kafka clusters, and everyone shares them. We've got a few special purpose clusters, but there are some big clusters that everyone uses, and the first of these is tracking and data deployment. These are actually two clusters. Tracking is what we call all the data going to HDFS. This is mostly user information, so things the user has done, clicks the user has made, connections that they've made, shares, information that's used for the relevance algorithms. Data deployment is everything that's coming out of Hadoop to online applications. So when somebody runs a job in Hadoop and they need to export the information out to an online application, for example, a search index, it would go out through our data deployment clusters. So this is two pipelines we have. And I'll talk about how the pipeline works as far as the multiple tiers that it goes through in just a few minutes. So these clusters have many shared topics. For example, we have a single topic for page view events, and lots of applications write into that because we have lots of microservices on our website that do different things. So you may see 100 different applications producing to the page view event topic. As such, because they're shared, we have very strict requirements around message schema in the tracking pipelines. Everything requires a common header. And because we have a common header that has information like service name, host name, what member ID it's associated with, if a member ID is appropriate for that data, all the message counts can be audited. I'll get into auditing in just a few minutes as well, down towards the end when I get into the problem section as far as what exactly we mean by that. So these clusters have some special problems. If we start dropping messages for some reason, usually this is because an application is dropping messages when it's producing them, because all of my applications are perfect. It's hard to tell who that application is. In a topic like our page view event topic, we have to then dig into the audit data to find out exactly which application it is that's having problems, and sometimes exactly which host is having problems, because somebody's deployed a canary version of an application and it's bad, and they didn't bother to check their log messages when they rolled it out, so we have to tell them that they have a problem. We also have a lot of duplication of tracking messages. Some of our messages are copied up to 42 times in our infrastructure. That means there are 42 copies of an individual message on disk somewhere. We have local tracking clusters, we have aggregate tracking clusters, we have aggregate tracking clusters in Corp, we have Hadoop that has a replication factor of 3, we have RAID going on, so that's another copy. There's a lot of waste in some of this, and so we've got a lot of disk space that's taken up by this. But But at the same time, we need to maintain the reliability of this data because this is what our users are doing. And when somebody clicks and connects with another user, that we want that to be reflected in the search results immediately. We don't want to have to wait for database changes to propagate down, get processed on a daily job, and then get pushed back up. We want the search information to be able to pull it directly from tracking. Our next big cluster is metrics. Now between metrics and tracking, these are our largest clusters in Apple. Metrics is everything you can think of when it comes to metrics. So this is application and OS metrics, deployment and build system statistics, service calls. All of our applications take a sampling of service calls that come into it and produce timing information to a metrics cluster so that we can track information. You can also do debugging on requests. So as an application developer, I could go in and say, I want my messages from my from my member ID to be debugged for a short period of time. And then I can go and use an application we call call tree to diagram the calls as they go through our system and see what all the timing is. So this is produced to the metrics cluster. We've also got some application logs going in here as well. We're starting to move them out, but there's still a lot in here. So, special problems here. Every single server at LinkedIn talks to this cluster at least twice. Once for the OS metrics and once for the application. And that doesn't count if they have multiple applications running on that host. We also have our alerting system. We have a wonderful self-service alerting system called Ingraphs. Ingraph System Monitoring System. Auto Alerts is the alerting system. Anyone who's developing an application can just annotate a bean in their Java application, and it gets sucked into the metric system, and it gets a graph, and they can start alerting on it. They don't have to coordinate with anyone to do this. But our wonderful alerting system actually consumes the metrics data 20 times. There are 20 different servers in a given data center that store metrics on disk, and each one of them consumes the entire stream, throws away 19/20ths of that data, and then writes 1/20th of it to disk for whichever metrics it's responsible for. So we've got some challenges with that cluster as well. Logging. Okay, we're moving our logging out of the metrics cluster because if the rest of the developers are anything like my developers, they like to log way too much. If you're running Kafka, I'm sure you know Kafka is a very chatty logger. They're not alone. Everyone wants to log all their information, even if they never read it. The complaint is always, well, when I have a problem, I really need all that data. Okay, fine. So this stuff is all destined for ELK clusters. It's not replicated out of the data center that it's in. It has lower retention because all we're trying to do is get the messages from the server into the ELK cluster. We need 2 days worth of retention at most, and even that's overkill. We probably only need a few hours worth of retention. Yes?
For metrics, what are you using? Are you using Grok Wizard or?
No, it's an internal system called Ingraphs. It's completely homegrown. We used to use Xenos and then moved away from Xenos and wrote our own system. The storage is all backed by RRBs right now, but everything else is custom. So this cluster also has the loosest restrictions on schemas. I really don't care what anyone writes in here as long as they're able to read it out because it's going into their own ELK cluster. So if somebody wants to write raw JSON in here, that's fine. Every other cluster, we require Avro encoding. Now, if I'm talking a little fast, it's because I want to get through this really interesting stuff. So there's not many problems with this cluster. We significantly over-provisioned it. We're actually probably only at about 5% utilization right now. So it doesn't have a whole lot of issues because there's so much capacity, nobody cares about any problems that are going on. But we do have some customers who are starting to ask about aggregating this data, and it's something we can't do for security reasons. A lot of the logging messages sometimes have information that we would rather not replicate out to our environments that are less secure. So we want to keep this data within a prod data center where we can assure its security. We don't want to replicate it down to our corporate environment where developers have much freer access to things. And you can't be quite as assured that there's not crosstalk between things going on. So we definitely want to keep this more secure. And if I try to aggregate anything, the security guys will get angry about it, which is really funny because they're one of the ones asking about aggregation. Queuing is our catch-all. It's everything else that's going on. This is mostly messages that are applications talking to each other. So an application queues up some messages, processes it in a different part of the application. We also use this for user messaging, including emails. So applications within LinkedIn that want to send an email to a user will push it into the queuing cluster in a special topic. And then the application that does emails will pick up those messages, decorate them, and then send them out. Now, many of you probably receive far too many emails from LinkedIn right now. I'm happy to say that we actually have things that have gone in place in the last year to significantly reduce the amount of emails. One of these is called ATC, Air Traffic Control. And it's designed to take these email messages and consolidate them, send them out at appropriate times of day, and in general, handle the emails in a central fashion. This means that when you write an application within LinkedIn that needs to send messages to a user, you don't have to worry about what the Chrome on that email is supposed to look like right now. You just have to send the email to the system that's going to send the email for you. It worries about everything else. So all of these messages are Avro encoded, but we don't require headers on these because most of these messages stay in the queuing cluster. And as long as the application that is going to read them can interpret them, we don't need to worry about the encoding besides that. In the tracking cluster, all of that information is going to HDFS, and it's going to be shared by many different people, so we have to be a little stricter about the standards there. So a lot of the messages in here use unregistered schemas, which means they're harder to read for my applications. These message clusters also have really high message rates with small messages. Messaging and things like that tend to be very small. When applications are queuing data for themselves to read, those tend to be very small messages, but you may send them very, very quickly. So these clusters appear to have low utilization when we look at the disk usage, but they have high utilization from a messages per second rate, which complicates our planning a little bit. Especially, we have our SAMSA clusters. We'll do a lot of work in here writing intermediate data, and they tend to cause a lot of problems. Like I said, we have a few special case clusters. Not everything fits multi-tenancy. People have custom configurations that they want to use. Security, maybe. They want to use topic deletion. Oh, I'm going to talk about topic deletion a little bit. It's one of my favorite things to talk about. One of these is our internal key value store called Espresso. We've talked about it a few times externally. It uses Kafka now for internal replication in the system. So they have a lot of requirements around latency. They don't want auto-topic creation turned on. There's a lot of config changes that are responsible for that. Brooklyn, which is our new change capture system that goes along with it, it's open. It's going to be open source if it isn't already. So if you want a change capture system, we can talk to you about that. So this works with Espresso. It has a lot of the same requirements, so it also has its own cluster. We have another cluster that's similar to data deployment, but it's for a very specific use case that's replicating data from Hadoop out to our database called Voldemort, which they want to use delete topic, they want to use, they want to control the topic creation. They also want to push a lot of data. So we separate them out to their own cluster. Okay, I've talked about clusters. Clusters are great, but I have multiple data centers. I have multiple tiers of data centers. I have production data centers, I have corporate data centers, and I need to move all this data around. One of the things about how LinkedIn uses Kafka is I am the only person that does cross data center Kafka communications. The mirror makers are the only application that reads or writes messages between data centers. Every other application stays within its data center when it's talking to Kafka. If we are talking about failover, for example, if we have to fail over a production data center for maintenance or for a problem, we actually just shut off all the user traffic and move it everywhere else. We don't try to fail over individual things within the data center. So, how do we do this? How do we do our tiered architecture? This is one of our Kafka clusters at LinkedIn. Now, everything in this dotted line in the middle, I'm responsible for. This is an application that's reading messages, and this is an application that's writing messages at the top. Same thing over here. But I have my Kafka cluster, I have Zookeeper, I have a schema registry where we store all the message schemas. And then this box is the Kafka service because this tracker consumer and tracker producer is a library that we provide to all of the people who are developing applications within LinkedIn. They don't have to write the code that talks to Kafka and talks to schema registry and talks to everything custom internally. All they have to do is compose the message and producer.send, and everything else is magic. Keeps it very simple. It also means we have a good deal of control over what's going on. So we can do things like support extra large messages by breaking those messages up into chunks, sending them into Kafka in individual messages, and then reassembling them on the other end. So this is one cluster. What does it look like when I have multiple tiers and multiple clusters? This is an example of 3 data centers. Now, data centers A and B are production data centers, and data center C is one of my corporate data centers, one of my corporate data centers. So we have a local cluster, and we have an aggregate cluster here. The local cluster is, for example, what I called tracking earlier. That is a local cluster. All of my producers talk to the local cluster. And I have some consumers who are only interested in data from one data center that are consuming out of that cluster. To compose my aggregate clusters, I have mirror makers running that then write all that data into aggregate. So in production, I have limited aggregate clusters. So this part where I consume it to data center C isn't quite right here. We actually do that out of the local clusters, but if I tried to put it on here, this slide would be a complete mess. You just asked the Microsoft guys when I tried to do it earlier. So these actually have a limited number of topics, whereas my corporate data center has all of the tracking topics. The reason is all of the topics have to go to Hadoop, but not all of the topics are used in production by online applications. So I have two production data centers here and 1 corporate data center. I actually have 5 production data centers and 3 corporate data centers right now. So you can imagine that these nice single mirror makers here, each one of these in this diagram is actually 2 different instances of mirror maker. Okay, multiply this out by 5 and then multiply the other side of it by 3, and you get an idea of how many mirror makers and how many paths we have going on here. Now, why don't we allow direct access to the local clusters? Why don't we just have cross data center Kafka and let the applications talk to who they want to? One of the big concerns is networking. Bandwidth is a problem. Kafka is great because it lets you consume data that you've written in multiple times. But if I let people talk to the local cluster in every data center and they want to consume page view event, and if I have 2 applications that are both consuming page view event, I've just wasted a ton of bandwidth by copying that data over the network twice. We also have issues with network partition. If you get partitions from one data center, how does the application handle it? So we'd have to add a lot of logic in to deal with these network partitions and how you recover from them. And then, of course, there's latency. Kafka tends to deal with latency okay, but applications often don't. They don't know how to respond if things slow down. So if you're dealing with just a local connection, that's very fast. Even if you poll and there's no data because it's slow getting there, you're still polling and you're still working properly as you do that. Another concern is security. So I have firewalls and ACLs between all of my data centers. If I'm the only one doing cross-data center Kafka, then I only have to punch one set of holes through the mirror makers, and I can control who can talk between data centers very clearly. If I let everyone do it, then you may as well just open up the world to everyone. And again, that makes security cranky, and if security is cranky, there isn't anybody who's happy. We're also getting to the point where we're encrypting all of our data. I have a data center overseas in Asia. I don't really want to send plain text messages, and you really don't want me to send your plain text member information across the Pacific. There are numerous people who are tapping those cables, so we want to encrypt everything. If I'm the only one doing the talking, then I'm the only one who has to worry about the encryption. I'm the only one who has to take the performance hits, and I can assure that everyone who is talking is doing security properly. We also have some resource concerns. We only let Hadoop talk to our core aggregate tracking clusters because the way Hadoop consumes messages from Kafka is it starts up 1,000 mappers. and they all connect to Kafka to pull some messages, and they do that for a minute or two, and then they shut down. And then 10 minutes later, they do it again. Those 1,000 clients tend to cause a lot of problems, and I don't want them talking to production, because if the production cluster shuts down or has performance issues, then that affects front-end applications. If I cause the same problems in the corporate cluster, it's not as big a deal. That slows down, but it's on the back end. Nobody else notices that kind of problem. So what do we lose when we do this multi-tiered architecture? You're going to lose message ordering. There are some ways around this. I'm going to talk about it a little bit at the end, provided I get there. But Mirror Maker breaks apart all the message batches and redistributes the messages to different partitions. So you tend to get a little bit of out-of-order messaging. Now, all of our applications internally know about this. Most of them are just fine dealing with it. We have a few that have stricter requirements, and we're putting in place some controls on Mirror Maker for just them to make sure it works. The other thing as part of this is that you can lose message to partition affinity. If you're producing messages that are keyed, they go into a specific partition when you produce them. If the partitioning is not the same on the aggregate cluster, then all the messages will end up in one partition, but it will be a different partition. As long as your application's okay with that, it's not a problem. If your application is expecting things that went to partition 0 to be in partition 0, then you're going to have a problem with Mirror Maker. Particularly because Mirror Maker doesn't by default honor custom partitioning. So if you use the default partitioner, it'll tend to work okay as long as your partition count is the same. If you use a custom partitioner where you actually assign the partitions yourself, then you're going to have a problem with Mirror Maker unless you go ahead and put that same custom partitioner into the Mirror Maker. I have some rules for aggregating data. The biggest one is that aggregate clusters are only for consuming messages. I've actually had some questions about this from a few people who have seen me very adamantly say that you do not produce to aggregate clusters ever. The reason for this is that I want to be able to assure that all of my aggregate clusters that have a specific topic have exactly the same messages in that topic. So I need to be the only one via Mirror Maker writing messages into that topic. If somebody else produces messages into an aggregate cluster in one data center, they will not get propagated to the other data centers. Another one is that you don't have to have every topic in every aggregate cluster. As long as you know which ones are where, and the ones that you need are in the places where you need them, it's better to not have as much data in prod if you can avoid it. One of the nice things about getting the data out of prod as quickly as possible is that prod is where all your attacks come in. So if somebody attacks your production environment and compromises your systems there, but you've already moved the data out to somewhere else, and you're not storing 7 days worth of data in somewhere where you don't need to, you've reduced your risk. Now, all of our data makes it down to court because everything makes it to HDFS. So we try to tell people that, well, if you want aggregate data, you should really move down to court or move down to HDFS, move down to the Hadoop if you can deal with offline processing. The more I can get things out of prod, the smaller I can build my production data centers. This is really important when you're trying to build small data centers in remote locations to take care of user latency issues. And then I do have aggregate queuing clusters. We tend to talk about aggregate tracking because that's most of what gets used. I do have aggregate queuing because I have messaging use cases that want it. We restrict this very severely. We probably only have 24 topics that are mirrored in aggregate queuing right now. And we make everyone talk to us about their use case. So we force them to come to us and say, we want something added. Then we tell them that they have to adhere to very specific message guidelines when they do that, and we want to know all the sizes. So, awesome. I'm down to the interesting part now, and I've still got a little bit of time. So, buy my book. One quick plug. I am in the process with my co-authors, Gwen and Neha, of writing a definitive guide for Kafka. You can get early access now on O'Reilly. We're starting to add some pretty good information about Kafka consumers and producers, and some basic clustering and configuration information. Yeah, that's enough of that. So monitoring, and I'm probably going to have to speed through a little bit of this unless I take up all the time. So monitoring is self-service. We don't have a gatekeeper on what people do. We have a common container where you just have to annotate the metric in your application, and it automatically flows all the way through. Then we get the service calls, the application logs as well. So everything's produced to Kafka and it's consumed by our monitoring infrastructure. Now, when I started 3 years ago, that's how everything was, including Kafka. Kafka was monitored with metrics that went through the metrics cluster to the monitoring system. You can imagine how much of a problem this can turn out to be. So we actually have a system called KMON and a notification system called Enlighten now, which are general purpose monitoring applications. And I will post these slides afterwards, so don't worry as I click through these, all the information will be there. So the only rule is that I can't use Kafka when I develop this, which has really been a bit of a restriction in some places when I want to try to queue messages between multiple instances. So our alerting is a great deal simplified from the self-service system that everyone else uses. I don't have to deal with regular expressions. I don't have to deal with RPNs. It's much faster than the system, and it's more reliable because it doesn't use Kafka. So I will see problems. I'll be able to keep seeing a problem when we are having an active issue with the data set. Our notifications are also a lot cleaner. One of the reasons we haven't switched to some commercially available system is because we've got a lot of stuff in place to aggregate alerts into incidents and only notify on an incident. So I might have 20 alerts going off for a Kafka cluster, but I only get one notification that says that there's a problem with a list of anything. We also set it up so we can use it for other things when we want to. So what do we monitor on the routers? Bytes in, bytes out, messages in, partition counts. These are the only things we alert on right now, under-replicated and offline partitions. If you have under-replicated partitions, you have a problem. You have to address it. You can dig into the rest of the metrics to find out what that problem is. There's a lot of good information that we're getting into the book on how to address under-replicated partitions. I also look at my thread pool usage and my request rates. This is all information that's in our monitoring system. Most of it we don't alert on. But what everyone wants to know is Kafka working? And I better have a good answer for this when somebody asks. Because knowing that the cluster is just up and running isn't good enough. The application owner is asking me if it's working, and from their point of view, I better be able to tell them that it is, and that the problem is on their side. So first I have to tell them what to monitor on their side. But I need to be sure about that answer. So we have this thing called the Kafka monitoring framework. This is open source as well. What this is that this is a special application. It produces to a special topic and consumes from that topic. It makes sure it got all its messages. It calculates latencies, and it emits an availability metric for us. So my SLO for Kafka is 99.99% availability. So if I drop out for more than a couple minutes a week, I've got a problem that I'm going to have to deal with. And in general, our Kafka clusters are always up and running. We have a little bit of noise in this availability metric, but most of them are 100% all the time. If it's not 100%, we've probably failed out of the production data center to deal with it. We're working on multi-tier support for this so that you can assure pipelines are intact and working. And here's the link on GitHub, provided GitHub is actually running today. Again, I'll post these later so that all the links will be there. So is my mirroring working? Kafka's working. What about mirror makers? All of our critical data flows through Kafka. We do executive reporting. I said this earlier today. If there's one thing that I don't want in my line of work, it's the CEO to know me. So his reports better be in his email box when they're supposed to be there. So I have to make sure all the data is mirrored down to the ubiquitous. We have tons of topics. They have different message rates. Some of them are more important than others. We used to do lag threshold monitoring. So we have 1,000 topics in a mirror maker. We pick one of them and monitor that one topic. And if it was slow, then we'd know we had a problem. Unless it was another topic that was slow and that one was fine, then we wouldn't know we had a problem. So what did we do? We've got two pieces of infrastructure that deal with this. The first is called Kafka Audit. So this tracks the completeness of a message stream. And I think, yeah, my next slide is good on this. So the producer produces message counts in addition to the messages that it produces. And then we have this audit consumer that consumes all the message, and it produces message counts in. Same thing happens in the aggregate clusters. And then we have this audit DB consumer that takes all of those message counts, and it says, okay, in a given 10-minute period, there were 100 messages here, and there were 100 messages here for this topic. Everything's good. If there were 99 messages in the aggregate cluster, then I know I dropped something somewhere, and I have to go back and figure out what the heck's going on. Because Kafka shouldn't drop messages under normal operation, it is at least once messaging, not almost once messaging. The other piece of infrastructure we have is Burrow. Now I wrote this earlier this year to address the problems with lag threshold monitoring. So what it does is it monitors all the consumers in a cluster all the time for every partition, and it calculates state metrics for each partition and then aggregates that into a consumer state. So this way you can look at it and you can say, okay, this consumer is in a bad state. You can dig into the information, find out what partitions are stopped or stalling or lagging, and get a good idea of whether or not your consumer is working. And you can actually have that across every topic you're consuming, so it's not just a key topic that you're looking at. So we now export these metrics to our internal system in Graphs so that all of my customers can have access to the same monitoring that I'm using for their data. So to start with, this was just for our stuff internally. Now we're exposing it for everyone. We've got a number of people who are using it internally to have better status on their consumers, because prior to this, everyone just relied on the max lag metric. I don't know if you know what max lag is, but it's the lag on the single worst partition that you're consuming. And the metric is only valid if your consumer is actually working properly to start with. So Burrow gives you an objective view of what's going on. And again, open source, LinkedIn/Burrow. Please help me, commit code, tell me about bugs. We do fix things, we do accept PRs. Mean time between to failure. So I've got over 1,800 Kafka brokers. They have at least 10 disks each, 2 CPUs each, 64, 256 gigs of RAM. I have hardware failures daily. So I don't want hardware to be down for any period of time, because that means I'm under-replicated in my cluster. Prior to Kafka 8, you couldn't move partitions at all. There was no capacity within the system to do it. You could hack around it, but you had to do a lot of work to do it and muck around in Zookeeper at a very low level. So it's still not easy. The tools that Kafka provides don't do this well. You have to explicitly tell it where to move what. So we wrote a tool called Kafka Assigner, another open source tool. What Kafka Assigner does is it takes simple commands like remove this broker. And it takes all the partitions for the broker and reassigns them to other brokers in the cluster. And it runs all the steps for you and tries to do it in a way where it's not going to impact the cluster too much while it happens. It also balances partitions. That's another thing that Kafka just does not do. It has no concept of how to balance partitions. So Kafka Assigner can look at partition counts, partition sizes on disk, and reassign partitions to different brokers to keep the load even. We've got another project, which I'm not going to talk about because my colleagues are going to talk about this in a couple weeks in our own meetup down in the Bay Area. So if you happen to be down there, take a look at our meetup group. It's linked at the end. Cruise control is going to do that automatically. So it's going to monitor the Kafka cluster constantly. It's going to move partitions around to keep everything balanced and keep everything fully replicated. So remember those 1,000 Hadoop jobs that spin up to read messages? They also spin up to push messages. So somebody pushes 100 gigabytes to Kafka to go out to prod, and they do it in the space of a couple of minutes and swamp the entire cluster when this happens. If they configure it badly, sometimes it's 2,000, sometimes it's 100, but they're pushing a ton of data all at once. It kills the data deployment from clusters all the time. We get a lot of spurious alerts for these. So this is one of the reasons that we developed quotas for Kafka, and this is in open source Kafka. So they're specified per client ID on a bytes per second basis. They're not per topic, they're not per partition. They are extensible, so you can write your own stuff if you want to make them better, but as a base quota, it's just per client ID. It's transparent to the clients. The broker accomplishes it by slowing down the responses that go back to the client. So the client sends a response. If they're over quota, the broker just holds on to the response going back to the client and makes them stop. Now, if you have a badly behaved client, this isn't going to work well, but as long as you're using the standard clients, it should be fine. So we're just using it to protect the replication of the cluster. We use it as a DDoS protection. That's it. We're using default quotas, and we're making sure that if a client starts to go out of control, that they can only hit a certain limit, and that we can still replicate data in the cluster. So there's still some overhead for the brokers to do what the brokers need to do. Yes? Yes, it is both consumers and producers, and the numbers are specified separately. So you can have a different quota for producers and consumers. You can also override it per client ID, and that's an online command that gets stored in Zookeeper, so you don't have to restart the brokerage to do it. Delete topic. I only have a minute or two to talk about delete topic. So this has been under development forever. We asked Neha to develop this when she was still working at LinkedIn almost 3 years ago. And up until very recently, it has never worked properly. Every time we've tried to execute it, it has killed entire clusters. We will not turn it on in prod. Now we're getting there. We've got people who need to use it, and so we're starting to turn it on in a few limited cases. It seems like it's working okay now. But we ran into a problem recently. We disabled delete topic, and something happened where a topic got marked deleted, and the brokers still did some work across delete topic. It turns out there was a code path that wasn't shut off, that wasn't locked out when delete topic was disabled from the cluster. And what ended up happening was the metadata was different on different brokers because the controller sent out metadata delete requests to the brokers, but the topic still existed, so the topic never got deleted. This broke Mirror Maker. We had all kinds of issues. The brokers are independent, and there's no easy way to send a request to a specific broker. When we got into this situation, one of our developers actually had to write a Java application to connect to a broker and get a send a metadata request and get a response, just so we could see what the difference in metadata was to try to track down this problem. So I was actually working on this earlier today. I'm going to be adding a new tool to Kafka Tools that is just a simple Kafka protocol CLI. Connect to a broker, send a request, get a response. It's not going to try to do anything smart. You tell it what to send, it will tell you what the response it got back was. That's all it does. So these are just some of the things that we've developed to solve our problems over the years. So we're working on JBot improvements. I'm not going to talk about this too much because I really don't have any time left to talk about it. But we're going through, we use RAID 10 for all of our brokers. We're trying to get away from RAID 10 so we can get back some capacity. I'm happy to talk about this afterwards with anyone who's interested in JBot as well. We're also working on improvements to Mirror Maker. We're trying to make Mirror Maker more efficient by taking the compression and decompression out of the loop and solve the message partition affinity problem by having an identity Mirror Maker that just reads from one partition and produces the same partition. And then we're working on cluster management, client monitoring, Burrow's one. We want to try to get an open source solution for audit because Confluent solution is not going to be open source. You're going to have to pay them for it. I like open source. Open source is where I've made my name, so we will continue to do that. LinkedIn's very good about that too. It's one of the reasons I love working there. And actually, I should say it's one of the reasons I love working at Microsoft pretty soon. And then end-to-end availability monitoring through Kafka monitoring. So lots of ways to get involved. If you do happen to be in the Bay Area in a couple weeks, I think it's November 5th is our meetup. We do have a meetup coming up. Just meetup.com, search for Kafka, you'll find it down there. Get involved, contribute code, IRC, and that's it. I don't know if there's a space to delay by a few minutes to answer some questions.
That's okay.
Okay.
We'll take some questions.
Yes.
I was just curious, you talked about like operational, like how to run at large scale. I was just wondering, like, when you're developing applications on this stack, do you have any, like, based on your experience, maybe, what are some of the things that, as you're developing solutions that leverage the stack, is there anything you would recommend?
So leveraging the Kafka stack and scale, largely it's around making sure that your consumers process things quickly. So the scale problems tend to come in on the consumer side and not as much on the producer side. Because you can just throw messages in all day. You don't have to worry about how much data you're throwing in. You're limited by your network, and that's most of it. When you're consuming messages, you tend to do processing on those messages, and that takes some amount of time. So you need to be concerned about how long it takes you to process a message, and when do you want to commit your offset. So when do you want to acknowledge that you got that message? Do you want to wait until after you've done your processing? Or are you going to do it before you do your processing so that things can continue moving forwards? And that's largely an application issue. The other thing to worry about is deduplication. As I mentioned, Kafka is at least once messaging. That means you are going to get duplicate messages. and you need to be able to take care of those appropriately for your application. Those are probably the bigger things. In general, just making sure that whatever you're developing can scale horizontally, so that you can take advantage of the fact that Kafka can push all this data through.
So your dev folks, are they, like, for example, for dev tests, like, are you using like some kind of a Dockerized?
There's a locally deployable version of Kafka that so they can deploy Zookeeper Kafka and the schema registry locally, so they can do local testing with it. Yes.
So back to your opening about the aggregates, not doing aggregates.
Mm-hmm.
So my question there is, you don't want to do the aggregates because PI data can float into the aggregates.
Yes.
Okay, so just a big scientific wild ass guess, are you kind of working with the Hyperledger folks at all on any sort of separation between Kafka and the like keys that would separate you from those aggregates?
So we generally work in member IDs, and because of the nature of the data, we really can't separate it too much. The data, so the security guys complained at one point about the user request event topic, and they said, oh, it's far too easy to track what a user's doing. And the response from our tracking team was, good, that's exactly what we want. We just want to assure that the right people have access to it on the back end. Mostly what we're focused on right now is adding the encryption in and adding ACLs to make sure that the right people are producing data and the right people are consuming data. Outside of that, most of the people who want to do aggregated data, like aggregated accounts, are already doing that. We have pretty good controls in place by the security team for detecting when the wrong data has gotten into topics that it shouldn't be in. For example, log messages. Wander down this way so I don't need to go everything down here. Yes? So we're running a version of Kafka that is ahead of release. We don't run released versions of Kafka. We generally pull a trunk version once a quarter, and we'll test that, we'll deploy that trunk version, and then we'll cherry pick a few patches over the next couple months before we pull trunk again. So right now, we're running a version of Kafka that is ahead of 0.10, but is not quite, I think they just released 0.10 or 0.10.1. I think that's the release that's just come out. So we haven't gotten to that point yet. We're just about to catch up to trunk again sometime in the next month.
So you are using the
Yes, yeah.
So the question here is
Yeah, we haven't switched to 3.5 for Zookeeper because it's still considered alpha or beta quality. Our Zookeeper ensembles are 5-node ensembles. They run with SSDs, so we actually have no performance issues whatsoever. Most of the performance issues with Zookeeper are related to consumer offset commits. So if you switch to Kafka committed offsets, you won't have any Zookeeper offset problems because it's using Kafka instead of Zookeeper. And we have one Zookeeper ensemble for an entire data center's worth of Kafka. It's isolated for just Kafka, so we have other Zookeeper ensembles for other applications, but all the Kafka clusters in one data center use the same Zookeeper. Yes?
So here, we are just a consumer of Kafka, so we build application of Kafka. On this one, what's the best practice? Should we have one office or schema? Or they could be multiple schemas in one office?
So we generally have one schema per topic. Most of that is a restriction based on how we consume things into HDFS. In general, you should have enough topics so that your consumer does not throw away any data. So you want the consumer to read the data and act on all the data it's read. If you read data and throw it away, you're being wasteful. So that's a case where you want to look at potentially separating out the data into multiple topics. In general, Kafka deals in partitions. Topics are logical groupings of partitions. So you can have lots and lots of partitions without a problem. It's not an issue to have multiple topics. It's really just an administrative issue of reducing to those topics and then consuming them.
So
So another question. So right now we're using
Last question.
Yeah.
Good.
it's a like an outlet.
Sure.
So we're using Kafka body and we are storing the offset in the broker. We have a broker. Is there any command or something we can set the offset like to any point of time?
So offset commits in Kafka are they're really just a produce message. So you'll have to do it yourself. There isn't a tool to do this in Kafka. But you can just send an offset commit request to the broker via the protocol for whatever you want to do.
No, so we're doing it, but I just want to reset it.
Right. If you want to reset it, then what you need to do is you need to stop the consumer, send an offset commit request for that consumer group, and then restart the consumer, and it will pick up from that point. It's the only way to do it. Happy to answer questions later and once we're done here. Thank you.
Thanks, Todd.